Chevy pickup here. This is a 2021 with a DFM equipped engine. This is the 6.2, and I'm rather excited to get to working on this one. We are going to be doing a full mechanical delete of the DFM system today. There are some rumors I'd like to dispel, one of which is the camshaft. We're going to kind of address the whole scenario and go through and do the delete. I don't expect this video to be the complete process. I expect it to be a cut down version of the teardown, and then we'll do a put back together version as well. And that one is going to be more heavily guided than this one. This one will be a little bit quicker because teardown is more or less just taking things apart. I'll point out some key details, and with that, we're going to get started. You can see I already partially took this thing apart. Now, this is a continuation of a live stream that I did. Feel free to check out my live streams. Maybe I'll put a link in the description below. On that live stream, the last thing I left off with was the actual problem of the rotated or spun lifter from a bad plastic guide. Now, these things are prone, and by these things I mean DFM, AFM, all of them, all the way down to 2007 when they first started AFM in the trucks, and 2005 when they started AFM in the cars. They are prone to rotating a lifter from a bad plastic guide. When this happens, the lifter will actually damage the camshaft and wipe out the cam lobe. Initially, the cam lobe will still have plenty of lift because it just scratches it, but the problem is, even if you put a lifter in this thing, it's going to chew up the camshaft further afterward, because the camshaft nick that's damaged from the initial spinning of it will damage the lifter roller, and the lifter roller will damage the camshaft, and it's just a cascading effect that continues and destroys everything. Now, if you want to see the diagnosis process, the live stream is where that's at. While I'm at this position, it sat overnight since the live stream that I did. I want to look at the rocker movement. Now, this is supposed to be a DFM delete video, so we'll get right to that in just a second, but I interrupted because I started going on a tangent about how to diagnose a spun lifter from a bad plastic guide. If you want more information on that particular portion of things because you're interested in figuring out if you maybe have that scenario, go ahead and click the link in the corner. It will be sitting right there for you whenever you're ready. But otherwise, we're going to get back to the delete part of this video. You can see I have a lot more tore apart than where you saw it last, but you guys will get there in just a second. I pulled this cover off of here. There's an air tube that goes to the air box. That's how you have to pull the air box out in order to access the computer. This thing, in order to do a full DFM delete on these units, this is the E90 ECM. And I think it's from 2019 on to 2022, I think is the range they give. It's on HP Tuners there. You have to send this out to get it unlocked. So here's the actual ECM itself. We got E90, and then there's this service number right here, 127-11852. And if you look on HP Tuners website for this service, you can enter the E90 ECM, and then you put the upgrade, and the numbers for that service number are right here. And we have the 1711852. So this one fits this criteria. Note, only the 2019 to 22 E90s are currently accepted. You have to do this before you can even try and tune this thing. So I'm going to do it right now. I'm going to send this thing out. When it gets back, I'll put it in, but it does not look like there's any estimated times on how long this process will take. Knowing from experience with HP Tuners, though, it can take a couple of weeks, unfortunately, depending on how busy they are. So I'm going to send this out first thing tomorrow, and that way I can get this out as soon as possible and hopefully get it back before I'm done with the vehicle. That way I can assemble it while I'm assembling. Then I have to go into the computer itself with my HP Tuners box and all that fun stuff. I have to pay for 6 more credits. Now, each credit currently at this time costs $50 from HP Tuners, so that's $300 just in credits alone, plus $300 for the computer. So just that is $300. Now you have to ship this out too, so that's additional costs. You got the shipping, all kinds of extra costs. So this is basically a $700 process when it's all said and done, even if you pay somebody working on a real cheap budget to do this, just for the computer side of the tune. So this is a relatively significant expense to doing the DFM delete. However, one way you can look at it is you have to replace all the same parts if you were to leave it stock, but the lifters on the DFM lifters are much more expensive per lifter than it is for the standard style lifters. So you can actually make up that cost pretty much, I mean, a good amount of it, just in the lifters alone. So it's well worth doing because it eliminates so many problems of the DFM and AFM systems, and it's just something that you have to eat. It's a cost that you have to eat. So, all right, I'm going to continue getting it apart. I already have everything draining. I have a couple pieces off the bottom. If you didn't see the live stream, in that I was talking about the history of this vehicle, which might be important. This thing was in an engine fire situation at one point. It's got a salvage title because it had an engine fire. The engine fire was not so severe that a bunch of plastic was replaced. It's just a lot of it's kind of melty. We have this little tab back here. It's a little bit melty. The valve cover, the little plastic pieces that go over top of the valve cover, the back side of them is a little bit melty. So there was some kind of fuel system failure, leaked down the back of the engine. I could tell it got down towards the transmission because the transmission bell housing area has some soot on it. So they must have put it out somewhat quick. It didn't do a horrible amount of damage, but it did cause some damage. And I think that's where all these tools ended up in here from whoever repaired that. There are a lot of cheap tools, so the guy must have lost tools a lot. So this one is a bit more tricky than the previous generation. There's a lot of little nitpicky things that are kind of bizarre on it. One of the things I forgot to mention altogether right at the beginning of this video, because I did it during the live stream, was the airbox thing that was on top of here. There's a little bracket on the alternator that sits up here, and you can't just lift it off of there. It's got a thing that you got to rotate that box up 90 degrees, and then you can slide it out. It's got to be lined up perfectly. So little stuff like that is kind of where this thing is real weird and finicky to deal with. Another one of those situations comes into play for the radiator. You can see this is the AC condenser, so the radiator is out, okay? You have to take the radiator out in order to get the clearance for the camshaft to come out, and I like to pull that stuff first just to make it easier to work on the rest of this stuff, okay? So I know I have to pull it, so I'm just pulling it. With that in mind, you can see I'm missing a part here that was here before. The fuse box that I had to use to jump the starter, I pulled it out because the oil cooler line, the engine oil cooler line, which is way over here right now, you can see this it's got a weird 90-degree oil cooler fitting here, this weird block. I think I could probably rotate. Yeah, I can rotate. This little block here, the reason they did a 90-degree block like that, they don't give you enough clearance between this and the actual fuse box itself. You can get this piece of plastic back, get the clip off, and slide this off, but that's the extent of it. Past that, you can't do this. There's a bolt here that's hiding. This bolt is right in the way of that box. So in order to get at this bolt, you have to pull that electrical box off. So that was one of those things where I'm like, come on, GM, what are you doing, right? So kind of stupid. And then I have to pull the fan shroud. So I had to take that stuff off to pull the fan shroud because these lines are all attached to the bottom of the fan shroud and they're in the way for the fan shroud to come out. So I had to disconnect and just kind of push them back. So I had to pull this off to push those back. Then I had to get at the fan shroud bolts, and there's two of those. And in order to get the fan shroud up, I had to disconnect. There's a transmission cooler line. I don't think you can see it, or transmission cooler here. But there's a transmission cooler in the front. You may or may not have that option. I don't know. It's a little line, comes around the front, and it bolts onto the front of the condenser here. See if I can get this picked up. So you can see right here there's a slot. It slides in on this side. And then on this side over here, it bolts into this weird little plastic doohickey on the other side. And that's how the transmission cooler actually attaches to this, the auxiliary one. I'm going to do this job without discharging the AC. So I disconnected as much as I could from this guy here, and I noticed there is no lines on that side, which is nice. GM's pretty good about that typically, but there is not enough room to push this towards the front of the vehicle and try and get that camshaft out. I can tell the camshaft is going to be too long for this. In fact, I have a GM camshaft right here. This is a old generation 1 or 2 LS-based engine, but I can kind of eyeball it here. So the camshaft has to come to about there. So it has to come past this, and I can't get that AC past this. Now, there is going to be a few other tricky things. For example, see if I can get this off of here. There is a lot of this kind of stuff around the radiator. This is a shrouding material. So you can see how it's got a channel right here, right? This channel is what goes around what's called the receiver dryer on this AC. It sits around here like this, and it's got these little rubber holes in it And you can see this one's torn. I may have just done that. This one has a slot in it. That's probably for a line that goes through. The other side has 3 of these holes, and if you're working on the vehicle, you know, within reasonable time of me posting this video, they're still going to be pretty damn stretchy. But if 5, 10, 15 years from me posting this video, you're working on this vehicle, and you try and stretch this around that plastic tab, you're probably going to rip this and damage it. If you lose this, it's probably not the worst thing in the world. But if you can salvage it, definitely put it back on. But these things are kind of tricky to work with. You can see this weird slit, clippy-do is what we'll call it. This goes to one that goes across the bottom. There's the same type of thing on the other side. And then there's a top shroud that goes over this. And you can see this weird hooked deal. It actually hooks into here on both sides. This side has a little bit different design than this side does. But if you look at it when you're taking it apart, you'll be able to figure it out. It's just a little tricky and kind of a pain in the butt to deal with. It's fussy. Another thing to help you guys work on this here unit, I've learned with these tabs, there is a tool for disconnecting these. I personally like to just pop the clips off. You just got to be careful not to make it into one of those Jesus clips, you know, where you go, oh, Jesus Christ, where did that go, right? These little clips, they like to fly if you don't hang on to them right and you pop them out. Just don't overstretch them, and you can pop them out and then put them back in later. Make sure you put them somewhere where you're not going to lose them. I only have them here for the sake of showing you. After I'm done doing this clip, I will be putting them in the back of the truck with the rest of the parts so I don't lose track of them, or back in the radiator. I'm going to get the intake, valve cover, and a bunch of other stuff off, and we will dig in a little bit further into what's more involved in taking this thing apart and getting the system done. I'm also going to be inspecting some lines because I have a feeling I got some burnt plastic lines on here. And I'll probably inspect some wiring too, just because I have questions about the fire this thing was involved in and how bad it actually got. I'm to a point where I want to show you some things when I do this. Now, I have covered fuel systems on these things quite a bit as far as the previous generation, the AFM versions of these. But I think it's important to do it here again, at least a little bit, because these things are just known for being a complete and total utter failure to deal with. Now, I do have the quick connect here disconnected. I was leaving the fuel line on here. I'm going to try something new here and see if I can just leave that on there and not cause any issue. It's really not in the way. I can just flop it over, do this fuel rail, flop it over, do the line. So it's really not in the way. I'm going to leave it there and see if I can avoid having to disconnect that second line, even though I already took the safety clip off. I'm just curious, more or less. So with that, we have the high-pressure fuel system here. And this is what's important to cover is these fuel lines are supposed to be replaced. Also, the seals on the injectors need to be replaced. Now, for the seal replacement, I'll just link you guys to a video where I did that long ago on kind of showing an idea of how you need to replace these seals. They are a bit tricky, but the part I need to cover in this video is the lines and the fact of getting these fuel rails off of here. They can be quite the challenging prick to deal with. These fuel lines are supposed to be one-time use. You're supposed to replace them. And theoretically, this is what was involved in the fire that this vehicle was involved with in the past. And that's why I mentioned the fire thing, is because these fuel lines are part of that. Theoretically, they didn't replace the fuel lines like they were supposed to. At least that's my assumption. Perhaps they did. I don't know. We don't have the full history. We just know this vehicle had an engine fire. And the engine fire was sourced behind the intake. I believe that it was probably these fuel rails or fuel lines that caused the issue. Somebody probably serviced them without replacing them, and they did not seat them properly. Now, there is a way, although it is risky, to save these fuel lines and reuse them if you'd like. I do offer a service kit on my website, crazedperformancerepair.com, but there is a way to reuse these lines if for some reason you have to. Like, say, for instance, you pull stuff off and you go to put it back on and you're just trying to test the system. Fine, reuse them for a little while, but replace them when you're done doing your testing. So the way to actually check these things or do these things is you go by feel. So you can see I loosen this one up. And if I bring this just snug, I'm going to leave it all the way at the top right now just for showing you something. I'm going to bring it all the way snug at the top of the line, okay? Now, if I push down on this, oh, now there's a really loose spot, right? I can snug it up more. Oh, there's another loose spot. I can snug it up more. Now it is lined up to the previous sealing point of where that was. And this one should be fairly lined up as well, but I'm going to wiggle and tighten with my fingers. And by doing that, now I could go ahead and tighten this line. And that would be how you would reuse these lines. So that is the reusal of this style of line, what happens to them, and the reason you have to do that. And the reason they're one-time use is because on this little sealing surface here, there's a small groove that gets created when you tighten this down. It kind of compresses the metal and creates a small groove in it. So you want to make sure you line it up exactly as it was when you pulled it off if you were to ever attempt reusing them. Now this one, like I said, was in a fire, and because of that, I'm going to have to address a few things. I noticed some of these connectors back here, like this one, for example. Oh, it's not undone from here. The clip is a little bit melted, but it's yellow, and that one is black. That yellow one is because I believe that was replaced at some point. This black one, I see some of the wires might have some exposed copper. So once I get all this stuff off of here, I'm going to have to inspect the wiring on there. I think a couple of the wires are melted together with some exposed copper. And you might think, well, maybe that was the source of the misfire, but clearly not, because the rocker wasn't moving when the engine was running. So clearly it's the mechanical failure that's the source of the misfire. But that could be a source of a future misfire. So I definitely need to address that while I'm in here. Now, as far as these fuel injectors and removing them go, obviously you got to pull these lines out of here. There is a 10 mil here. I already took that off of there. And you can see I've already loosened all these bolts. That was so that I could hopefully show this all in one uncut clip without having to do a bunch of video editing. But you're going to want a couple different tools here. So one option is one of these channel locks. And I bring both because it's nice to have a couple different things to pry on it from a couple different pry points. Another one, this is an indexable pry bar. This is really nice to have for this particular process. But there's one more that I actually don't have. It's basically the same as this, only it's got a point on the end. It's an alignment tool. And then it's got a smaller, much shorter hook on this end. And that might come in handy for this type of situation as well. But I've always managed to make do with what I have here. Now, when it comes to prying on this stuff, you really need to make sure that you're paying close attention to how you're prying on. Oh, wow. I barely put any pressure on here. It's already loose, okay? So if you don't have to put much pressure like I just didn't, it's going to be easy peasy, no problem getting this thing apart, right? So this one, look at that. I can pull it out by hand. So this one is easy. That I assume the other one's easy. Maybe somebody had these out at some point and that's why it's so easy. But if you do have problems getting these things out of here, yeah, this one's going to be easy. So I'm going to pull this out and show you, since I can get it out easy, show you where you want to actually pry on these if you have to put any amount of force on them to avoid damage. A lot of people make the mistake of damaging these fuel lines and subsequently ending up needing to replace them. So as you can see, we have a couple different seal things going on here. This little rubber seal keeps dirt theoretically from getting down to here and water from getting down to here, where it will cause it to corrode in the cylinder head and get stuck. Now, sometimes I've seen them where these are not in there. You can see this one's not on here, but I'm sure it's in the head because I see multiple seals here. So if these are ever not installed, it will get dirt in here, corrode the head, and it will be a complete freaking nightmare to get these injectors out. And you need to clean out the hole that the injectors go back in before you put them back in. Very, very critical step. I clean out the hole no matter what. Even these ones that came out easy, I'll be cleaning the hole, okay? So that is what these things get stuck by, is right here. This little area just gets completely seized, and that's what you need to get out of there when they're stuck. And to avoid that, you need to make sure you're very strategic about how you pry on this. So, as it's sitting in here, it's sitting like this, right? Or wait, wrong way. This way. There we go. It's sitting like that. And what you want to do is you want to take and find leverage points besides this surface right here that you can pry up as close to this injector as possible without prying on the plastic. So, trying to pry on this clip is actually a pretty good place because the energy will transfer from this clip to a metal tab that then goes directly to the fuel rail right above the injector. And you want to pry on this one then go to this one, then go to this one, and get as close to that as you can. Now there is on the back side here, you can pry over here on the metal tab, and it will go directly on this tab, which then subsequently goes on the injector part. So no matter what side you can get at it, as long as you're prying on this tab, you're going to be good to go. Another place that's fairly safe is these bolt areas, because they're right next to here. There's very little chance this will end up bending the fuel rail. What you want to avoid is prying directly under the fuel rail or on the fuel rail if there's any struggle at all. Now, in this situation, you saw that I pried right here because I was just putting it under here lightly, and it popped right up. If it doesn't take any force, prying there is no problem. But if you have to put any force to it, you want to stay near that injector. That is hugely important. So there is the fuel system side of things. I'm going to get this valley cover off of here, and then we're going to go into seeing the actual lifter failure side of things, and then I'm going to work on getting this balancer pulley off, which ended up being a bit of a situation in itself, which I will explain in just a second. So you can see I took a bit more apart. I made a video on can this be lifter release attempted, because I'm known for releasing stuck AFM lifters. Now this is DFM, so chances of that are pretty slim for it to have a lifter stuck because of an AFM failure like the previous generations. At least I think that's the case. We'll find out in the future, I guess, because it's still a relatively new vehicle, only a few years old as the time of this video. We have to pull the balancer off. Now, typical balancer pullers for this style of balancer is a 3-jaw unit with a little hook on it that you grab, and there's a little deal that it can bite onto. This balancer does not fit the typical heavy 3-jaw for harmonic balancers, and I had to modify it. So I will show you that in just a minute as soon as I get this off. But I also am going to show you the cam lobe that is damaged before we even get the camshaft out, because I just turned the crank to get it to that point where I could see it. Okay, so there is the balancer. You can see it's a press fit. I had to use this to get it off of there, of course. What I need to show you, though, is what I had to do to the jaws to make it fit. So here's the standard jaw that they come with. Now, I have several of these pullers. I bought one somewhere and ended up with a second one by fault of the manufacturer sending me a second one. So, weird situation, but anyway, I ended up with extra. So I had a total of 3 of these things, right? So I'm like, all right, I can just modify a jaw. It's not going to hurt me, and I'll use it in the future because I plan on working on these long into the future. So here's the standard jaw, and here's what I had to do. If I leave them in about the same position, look at that. So I literally cut the back of it so I could fold it over and then weld it. The reason I had to do that was because when this one is in here and you try and hook it like this, so this sits right now when I'm trying to pull this balancer, it's sitting about there, right? So if I match this jaw up to there, you can see the angle of this hook is not very aggressive. It's likely going to pop off, and on top of that, it can't quite get down to where it latches on here on the balancer. So it would literally sit like this, where it's, actually I should do it so you guys can see it better. It would sit like this where it couldn't quite bite on to that ledge. And then when I do this one, when I bring it out a little bit first and then over, now it's actually able to get a good solid bite on the ledge. So I had to do this just to get a hold of this balancer to pull it off of there properly. So little interesting note if you end up doing this yourself. But now I want to give you guys a glimpse at that actual cam lobe itself here, because it is a gnarly little thing. Okay, so it's going to have a little bit of a flicker, most likely in the screen, because this light here is pulse width modulated even on its high setting. But we're going to go ahead and zoom in here, or work the camera in, and then we will shine a light on this cam lobe. And I'm going to move the light around, and we'll see where the best position is for the sake of the camera to get a good look at that cam lobe and show you that position. I'll pause the frame whenever I need to. Now that you've seen what that cam lobe looks like, you can obviously tell why we had to crack into this engine. The one thing though is, from experience, I've seen a lot of these, that cam has been chewing up for a long time, okay? That is not it just happened on his way here. it has been happening since before that. The lifter just hadn't quite rotated yet. Either that, or the person who had this before replaced the lifter. But seeing the dirt and debris that I see along the cylinder head, where the head meets the block, I don't think that's the case. I think this thing just had a lifter chewing up for a while, and maybe the damage to the lifter is what gave it enough torque to rotate against that plastic guide and spin it around. So usually the plastic guide spinning is the source of that damage. This one looks different because it's just got too much chewing going on, considering how long ago I know that it rotated. He was heading across Minnesota. He stopped in Sioux Falls because it started misfiring and gave him a bunch of lights. That happened too quickly to chew up the cam that much. It should be just light scratching on there, maybe a small flat spot somewhere. Not that much chewing going on the cam. So something more serious has happened here. I'm going to get the rest of this apart. I can't stress enough the importance of getting those stupid designed AFM style lifters out of these things. And the fact that GM put 16 of them in there, stupid idea. But I guess it's more money in my pocket, right? So we will continue tearing it apart and be right back. So we'll get to the cylinder heads here in a little bit. I got those off. I have the oil pan off. And in order to get this oil pan off, this is the part I think we need to talk about a little bit, because it's a little trickier than it should be to get this oil pan off of here. So you can see this is lower. This is the steering gear. There is two smaller bolts at the very top above this frame, and you kind of got to manipulate hoses and wiring to get the socket on there. I used a short socket with an extension, with a wobble extension, and then I was able to get the ratchet out here and reef on it to get those two loose. And then these large, very large bolts here, these are what support this. Now there is a huge hole versus the size of the bolt, so this thing is going to be sensitive as to location and where it goes. I may need to get this thing aligned afterwards, we will see, but I'm hoping I can get this centered exactly where it was, basing it off of the marks that are in where the previous bolt was, is what I'm hoping I can do. And I'll utilize my little screw jack stand there to try and position it and hold it right in the middle, and then just kind of tip and work it back and forth, right? So there's that guy there. You also have to remove this cross brace, which is attached to the differential here, and then there's a bolt that goes through here that also holds this side of the differential, so you can drop it down to allow a little more room to work on the oil pan. And then of course there's a bunch of like wiring harness and stuff like this, like the oil cooler line, either bolted and or Christmas tree tabbed into the oil pan itself, as well as the oil cooler line, and all that stuff has to come off. And of course now I can finally access that oil pump, and that's the reason I went through all this trouble of getting the pan off. And I don't recommend you doing a job like this without pulling the pan, which is the reason why the AFM / DFM delete kits that I offer, the full DFM delete kits that I'm going to be offering, which will be on my website of course, they are going to end up coming with the oil pan related stuff, along with timing chain, tensioner, all that fun goodness. That way you can take this apart just like I did and be sure to get all the right components done with the job and not have any hiccups. So let's go ahead and get to the top of the vehicle so we can see what I did to get to the point that I'm at, and we can talk about what is the next step. So now you can see I have all these components off of here, and since I pulled the pan, I can take this guy out. And there's another noteworthy thing with pulling this pan, is make sure right here is where the dipstick tube comes through. You pull the dipstick out prior to pulling that pan, because this thing will give you a nightmare like it gave me trying to pull the pan out. I forgot or didn't realize this was on the pan rather than the block. Just didn't cross my mind at first, and of course I had to deal with that after I unbolted the pan. So pull this out first, it'll save you some trouble. So clearly I don't have the pump and pulley or gear off here. That's for a reason. There's a couple of critical details that need to be covered in regards to doing this part of the process. I already scraped all this gasket material off of here, and you can see some of it landed right on the pump, the dirt and everything. it's really not that important. It's fairly easy to clean once everything is separated. So I'm going to take all the parts off, clean the parts separately. I'll brake clean anywhere around the engine block area. It's all just going to drop to the floor or my pan that I'll have underneath because the oil pan's off. And that's another reason I like having the oil pan off. It allows you to clean things and it doesn't get trapped anywhere. It just all falls off, okay? Just don't go power washing the engine bay in this state, obviously. So little things like up here on this deck surface, if there's any dirt and dust, now is the time to wipe it off. That way you can get it clean. As far as this stuff goes, I have a couple of little brackets here. There's something aftermarket you can buy, and the point of that is to bump them up against this oil pump before you actually unbolt the oil pump. That way you have a retaining point for where the oil pump goes when you put it back on. So this allows you to just put it up there, push it up against your little deals, because gravity will drop it down. So you push it up against them, then you tighten it down, and you're good to go. You don't have to worry about the position or clocking of the pump anymore, because if you don't have those brackets there, you can turn it back and forth a little bit. So that's that part of it. Now, we'll go ahead and pull the pump out of the way. Then you have this bolt here. This is the cam bolt. It's actually a phaser actuator. It has a little plunger here. And we're going to talk a little more about this during the assembly process because there's a very important detail and a situation I ended up with on a AFM version of this engine, just a slightly older generation, that needs to be covered. But we'll get to that point when we assemble. As far as taking it off, I use an impact gun. Comes out pretty easy. It is a bolt that you have to replace, so this one that you pull off gets thrown away. It is a Torquillo bolt. Now when it comes to removing the actual cam phaser itself, you want to be sure to grab a hold of this part of it, not this piece. I've heard rumors of this piece separating, and there's a spring back there that causes it to become a problem, we'll put it that way. So you kind of grab it by that, you get the chain off of there. Now we have the chain and the cam phaser off. You're going to need this cam phaser to put it back together. You're not going to replace it unless you feel like spending a bunch of money. With that said, I'll go ahead and set this aside. Okay, now we need to remove, these are 10 mil, and these are going to be T40 bolts. I recommend an impact. Now, I did have one customer, he's probably actually going to watch this video, but he had an issue where these things on an older generation truck, the actual Gen 4, he had them where they would not come out. They were breaking his Torx bit and everything, which I have never seen before because they can't be torqued that much. But they do have Loctite in them. So if you end up in a scenario like that, definitely heat them up because the Loctite might be just holding it in place. Something tells me his particular vehicle likely had somebody who put red Loctite on there rather than the blue that the factory comes with. Now this cam plate here, this has a gasket on the back of it. So we do replace this cam plate. I send one with the kits that I sell. And of course, here's the camshaft. And there's a trick to making these a little bit easier to remove. One way is thread this guy back in there, the one you took off. Another is put an extension in there just so you have something to leverage, because the back half of that thing is heavy when you're on the very beginning of it, just pulling it out. Now, of course, if you have a weak wrist, you're going to want to use the extension factor, but I'm just going to go ahead and do it with this bolt. You want to be real careful pulling this guy out of there because you don't want to scratch the cam bearing surfaces. Here's the damaged camshaft lobe. Now before you get it all the way out, we're going to pull this bolt back out. And if this AC gets in the way, I'm going to move that up and over here. Oh, here's another wiped camshaft lobe. I saw the roller for that one, which we'll talk about in just a minute. Okay, it hits the condenser here, so I do have to move it. It's kind of what I figured. Now I only have to move it to clear, so I'm just going to lift it up a little bit and do this one-handed, just very carefully. There we go. Okay, now, the first thing you want to do when you pull this out is check your cam bearings, specifically the second one. First, I'm going to check this front one, just to see if there's any kind of weird grooves that I feel, and I got nothing. But in order to check these cam bearings, you want to take and flip this over. It's the second cam bearing that you're worried about. And the reason you're worried about that second cam bearing is because of this VVT situation. So in the previous, like Gen 4 engines, the second cam bearing could rotate, or not rotate, but get a groove in it and end up being very loose tolerance and therefore lose oil pressure. So what you do is you can see where these grooves are, right? You want to bring it so that your first check is when the groove is fully exposed, but part of the cam bearing or cam journal is in the bearing. And then you just want to take and lift up and down on this. Just a little bit of slop, okay? Then we want to go all the way in. We're going to feel the slop. It's got about the same amount of slop, so that half of the bearing is fine. Then we're going to go in and we're going to guesstimate about the same position as far as that groove goes, but on the opposite side. And we're going to do it again. There might be ever so slightly more slop, but it's not near enough to be concerned about. So this cam bearing is good. We don't have to worry about it. So now we're going to pull this tensioner off. Now, the Gen 4 stuff, we used to replace this tensioner with something called a timing damper. And the reason for that was because the tensioner was prone to failing, which it still is in these newer ones, but because the timing wasn't quite as critical on the older generation, the variable timing, we could get away with putting a damper in. Plus, this oil hole was not there on the previous generation. Now they have an oil hole here. This oil hole actually, I believe, controls the variable geometry oil pump, and that's why that's there. It's the pressure sensor area of the variable geometry oil pump. So this guy needs to be there, so I just send a new tensioner with the kits that I offer. And then, of course, this is the part that fails. This guy right here is a metal-backed nylon plastic surface. So what'll happen is this thing is, as it's getting used, it's being flexed by the chain, smacked by the chain, and worked. Every time you accelerate, it flexes this flat, and every time you let go of the gas, there's a kind of a slapping effect going on with that chain as it gets looser. So this thing will eventually break over time. Now, this is a Cloys part. So I don't know if Cloys is making it for the factory or if somebody has been in here before. If they were in here before, it's been a long time since they were in here. It has grooves in it, and all the bolts that I took out look like they've been in there for a while. So it isn't something that was recently done, but I think this engine may have been gone into at some point, which is what I'm going to talk about here in a minute with the camshaft. All right, you can see my parts pile here on the back of the truck. The nice thing about trucks is you got a whole bed to put stuff on. I typically like to have more rags. I'm going to have to degrease this bed a little bit. But this guy here, we have the camshaft itself, and there is some worn areas on this camshaft. I'm going to go ahead and wipe this guy down so it's a little easier to see on camera because we're going to talk about the individual parts here. Okay, so I have this lifter here. Was it that one? No, it's this one here. I have it in the position it was in, and then I have this one out of the carriage for a reason. So when I pull these things out of here, the first thing I do is I pick them up and I look right here at the rollers. And I sit here and I spin them and I look for damage on the roller, okay? Now, this one and this one have a line through them, but it's just a simple line. That's very, very common to happen. It doesn't cause any issues with the vehicle. It happens, okay? This one's a little bit different story. And then this one here is the one that I diagnosed with the actual issue in the first place. So this is the spun lifter from a bad plastic guide. Now, the other ones here are in the correct position. You can see this line in them, and you can see it's every single one of these lifters has that line in it because every single one of these lifters is an AFM lifter on these engines because of the DFM system. Now, this rotated lifter, look at this guide. This thing freewheels in here, okay? Now, here is the thing that makes me suspect about this particular engine. I think somebody may have put lifters in here at some point, okay? Now, I have two sources of evidence for that. One, the way the lifters are worn out versus the cam. Two, the cylinder head, the milled surface on the cylinder head almost looks like somebody used a granite block with sandpaper on it that they rub the head over or put on top of the head and just kind of sanded it, because it's not a machined surface anymore. It almost looks like somebody sanded the surface, which is definitely not the right way to do it. Can it work? Yes. Not the right way to do it, though. So, with all that in mind, let's take a little bit closer look at these lifters here. If I pull this guy out, well, first of all, before I do that, see how easy that spins? That is so worn out, it's beyond the point of where they typically rotate. Normally, they will have a little bit of stiffness on them, and you'll be able to rotate them. Let's see if any of these are close, where it'd be in that position. Okay, none of these lifters are actually in the position where I expect them to be right before they rotate. Usually what it'll be is, if you grab it, it'll rotate fairly easy. See, I just rotated that one, but I did have to put a bit much force on it. This one's close to that position where it's about ready. What you should be able to do, so if I pull it out more, yeah, there we go. If I'm at the end, I can make it feel like that. If it's in here, though, it's much harder to turn. So, how can I describe this? Okay, so if I'm going to pull it out. When it's all the way in, though, if you're able to turn it with your fingers like that, grabbing these two ends, this is the best leverage point because you have something to grip to, then it's too loose, okay? But, and it has the chance of spinning. But that's what I expect. Not where it's like this one, where I can freely rotate it like there's nothing there. There's no resistance at all. I mean, this thing freewheels in here, okay? Something is not right with this picture. Furthermore, we have this roller here, which I'll get you a close-up here as soon as I wipe down all the oil. If you take a close look at this roller surface, you see how that roller has no pitting whatsoever. The only marks on it are from when it rotated itself. There, right there. You see those marks? Those marks are from when it actually rotated the 180 degrees to get the flat on this portion. So those marks gouge the cam slightly. And if you look at the camshaft, you can actually see those gouges right there in the camshaft. But my problem with this whole situation is on the back side. This thing has such a nasty chewed up mark that chewed up mark tells me this lifter must have been replaced, because if that lifter had not been replaced, it would have had some marks all over this roller surface from this chewed up spot. Now, if we look at this lifter here, the one that I had sitting out, and we take a close look at its surface finish, you guys can't even see it, I don't think. But there is some very small pitting on the surface of this thing, but it's really, really small pitting. And if I look at its correlating cam location here, we have a slightly worn out cam lobe, right? So there's a little bit of damage to that cam lobe. Let's see what else we have damage to, because I didn't see any other lifters with an indicator. Okay, there is no other lifters, or rollers, cam lobes, whatever. There's no other cam lobes with any indicator to it. But the one thing about this lifter and this cam lobe profile that makes me wonder about the light pitting, this is a fairly smooth wear out, whereas this one here is severely pitted. I mean, it just feels nasty. It's got 20,000 pits inside this area here. And the one that's over here, it's more or less like a 120 grit finish. It's a really nice, not polished finish on this surface. So perhaps that's why this doesn't show the pitting much. And maybe this side was not taken off and replaced. I don't know. But there's no way this one doesn't show pitting while having a cam lobe that looks like that, unless this was replaced fairly recently. So maybe they just pulled off the head, slapped the gasket on it with a new lifter, and sent it down the road and wished for the best. I don't know. I can't find sufficient evidence to concretely say I believe that's the case. I'm just very, very suspect. So I have the thing completely torn apart. Now the next step is to take the cylinder heads, take them apart. I'm going to take them into the machine room, get them all machined, all that fun stuff. And when we come back, it'll be for the next episode during the assembly process. That way I can break into more of the details. It may be a multi-part assembly process depending on how I decide to structure the video exactly. I'm doing a little different format than I usually do to see how people like it and how they react to it, I guess. So, leave your comment below. Let me know what you thought. Here's all the pieces in the back of the truck. We will see you guys on the next video. Thanks for watching.